Here we have a rectangle that is bounded above by the semicircle and below by the x-axis. So right now this rectangle, it has a width of 6.8, 3.4 on this side and 3.4 on this side. And the height is calculated to be 9.4043. And so the area be just the length times so the length is this, and then this is the height. And the length times the height, which is 63.9489. And so as we change the length, then the height will also change. And we get a different area. And so the question is, what should the length be? What should this length and this height be, so that we get a maximum area? So we want to maximize the area. So now we have an area of 86, 88, 89, about 90, 92, 95, 96, 97, 98, 99, almost 100 area. And so it looks like the maximum is going to be around 100. So maximum area shouldn't be close to 100. And so it seems like the area, this side right here, should be close somewhere between 14, and the height should be around 7.1 or something. That's one to get the maximum area. And so now let's work it out. So we this point right here, this is x. And then the length right here would be 2x, and this is y. So this point right here is some x, some y. And so the distance from here to here is x. And so the entire length would be 2x. And then the height would be y. And so area would be the length times the height, and the length will be 2x, and then the height is going to be y. So this becomes 2xy, and so area will be 2x, and then times from the equation of the semicircle, and it should be y equal to 100 minus x squared. Not x squared minus 100. And so we multiply by this, and we want maximum area. And so since we want maximum area, then we need to find the derivative of a with respect to x, and then set the derivative equal to 0, and solve for x. So let's go ahead and rewrite this with the rational exponent so that we can find the derivative easier. So this is 100 minus x squared to the 1/2. So square root is the same as a rational exponent of 1/2. And then the derivative, this is a product, so we have to use the product rule. So it's going to be 2x times the derivative of the second factor, and then plus the second factor times the derivative of the first factor. Derivative of 2x, that's just going to be 2. And then the derivative of 100 minus x squared to the power of 1/2, we have to use the chain rule right here. So here the base is 100 minus x squared, and the exponent is 1/2. And so the chain rule is put the exponent in front of the base, and then subtract 1 from the base, and then multiply the derivative of the base. So that's the chain rule. So this becomes negative 1/2. 1/2 minus 1 is negative 1/2. The derivative of 100 is 0, and then the derivative of x squared is minus 2x. And now let's simplify this. So we have 2x times 1/2, which is x, and then times negative 2x. So that becomes negative 2x squared. Once again, 2x times 1/2 is x, and then times negative 2x, that becomes negative 2x squared. And then the 2 here, we can just put it in front. And then let's rewrite this using a positive exponent. So this is the same as 1 over 100 minus x squared to the positive 1/2. So now we get negative 2x squared dividing by this expression, and then plus this. And then let's get a common denominator here. And so what we can do is, since we're going to set this equal to 0, so we'll go ahead and get a common denominator here. Multiply this expression here by this. So we're multiplying the top and the bottom by the same thing, and this is just 1. And so multiplying this expression by 1, and we haven't changed anything. And so now this right here, the bottom, we're just going to have 100 minus x squared to the 1/2, and then this is 2 times this times this. But here the bases are 100 minus x squared, and so in multiplying, which is add the exponent, 1/2 plus 1/2 is just 1. And so again, this expression times this, which is at the exponents, since the bases are the same. A half plus a half is 1, so the exponent right here is 1. And so now this becomes, we have a common denominator of 100 minus x squared to the 1 half, and then the top is just this. 2 times 100 is 200, and then minus 2x squared. Minus 2x squared becomes minus 4x squared. And now we set the derivative equal to 0 and solve for x. And so we have this expression right here, and then equal to 0. Since we have a quotient equal to 0, and the only way that this could equal to 0 if the numerator is equal to 0. Since the bottom here, if it's 0, then we get undefined. So that has to equal to 0. Now subtract 200 from both sides. And then dividing by negative 4. Then we get 50. And then take the square root of both sides. So we get x is the square root of 50. And the square root of 50 is about 7.07, 1067. And we have the y is the square root of 100 minus x squared. And so in the place of x, since x is the square root of 50, we get square root of 50 squared. And square root of 50 squared is just 50. And so we get 100 minus 50, which is 50. So y is also the square root of 50. So the length of the rectangle is 2x. So this would be 2 times the square root of 50. And then the height of the rectangle is y, and this is the square root of 50. And then this is approximately 14.2135. And now we look back at the graphs here. Earlier we said that the maximum area should be around 100 with the height of about 7.14, and that's what we got right here. And the length, or this length right here, length or width, however we want to call it, but this distance right here, from here to here, it'd be around 14, so we got 14.14.